Good day everyone, welcome to my channel. So in this video we will talk about functional programming. Before we start, I would like to say thank you so much to Ma'am Brittany for allowing us to use this material, this presentation. Before we start, I would like to say thank you so much to all my viewers, silent viewers, and supporters in my channel. Thank you for watching my videos. If you are new with my channel and then you like this video, please hit the like button. Don't forget to share and please support my channel guys by clicking the subscribe button. So let's begin. Functional programming. Functional programming, or FP, is a programming paradigm that focuses on the evaluation of mathematical functions and the avoidance of mutable data in states. The roots of FP can be traced back to lambda calculus, a formal mathematical system developed by Alonzo Church in 1930s. Lambda calculus serves as a foundation for understanding computational and the notion of functions as first-class citizens. Brief history and origins of FP. However, the concept of functional programming as a distinct programming paradigm emerged later. In the 1950s and 1960s, the development of list processing language by John McCarthy and the work of John Backus on the development of functional programming language FP functional programming marked significant milestone in the evolution of FP. Lisp, created in 1958, was one of the first programming languages that embraced the functional paradigm, incorporating features such as first-class functions, high-order functions, and recursion lists. Flexible nature and support for symbolic computational made it an influential language for AI research in various other fields. In 1970s, functional programming concepts started to gain more prominence in languages like ML, or meta language, and Miranda, were developed. ML, created by Robin Milner, introduced strong static typing, pattern matching, and type inference, making it an important precursor to later functional languages like Haskell. Haskell, developed in the late 1980s by a group of researchers led by Simon Peyton Jones, is considered one of the most significant functional programming languages. It drew inspiration from several earlier functional languages and combined various powerful features into a coherent whole. Haskell is lazy by default, encourages immutability, and employs type classes for polymorphism. Over time, other functional programming languages emerged, including Erlang, Fsharp, Scala, Clojure, and Elixir, each with its own unique characteristics and use cases. Many of these languages have gained popularity due to their focus on concurrency, parallelism, and fault-tolerant programming in modern distributed systems. Functional programming has also significantly influenced mainstream programming languages like JavaScript, Python, and C#. These languages have adopted functional concepts such as high-order functions, lambda expressions, and immutable data structures, making it easier for developers to incorporate functional programming techniques into their code. Today, functional programming continues to be an important paradigm, especially in the context of concurrent and distributed systems, data processing, and big data analytics, where its characteristics like referential transparency and immutability are highly valued. So, advantages of functional programming, we have here concise, expressive code, easier debugging and testing, improved parallelism and scalability, predictable and deterministic outcomes, avoidance of side effects. Functional programming has gained popularity over the years, and there are several functional programming languages that are widely used by developers. There are some examples. Haskell is a pure statistical type functional programming language known for its strong type system and lazy evaluation. It has a strong community. It is used in various domains including academia, finance, and web development. Clojure Clojure is a modern dialect of Lisp that runs on Java Virtual Machine. JVM that emphasizes immutable and persistent data structures. It is widely used for web development, distributed systems, and data processing. Number 3, Erlang. Erlang is a concurrent, fault-tolerant functional programming language designed for building highly scalable and reliable distributed systems. It is used extensively in telecommunications industry, and building real-time applications. 4. Fsharp. Fsharp is a functional first programming language developed by Microsoft. It runs on the .NET platforms and supports functional, imperative, and object-oriented programming paradigms. Fsharp is used for web development, data science, and game development. Number 5, Scala. Scala is a multi-paradigm language that combines object-oriented and functional programming. It runs on JVM and is very popular for building scalable applications, especially in the big data and distributed systems domain. 6. Allcam. Allcam is a general-purpose functional programming language that provides strong type inference, and it is well suited for building high-performance systems and compilers. 7. Scheme. Scheme is a minimalist dialect of Lisp for its simple and elegant syntax. It often used for educational purposes and as a scripting language. Elm is a functional language designed for building web applications. It compiles to JavaScript. It is known for its focus on simplicity or strong type systems and architecture for managing user interfaces. Number 9, Racket. Racket is general purpose functional language and has a descendant of Scheme. It is used for various purposes including scripting, game development, and education. 10. Elixir. Elixir is a dynamic type language that runs on the Erlang virtual machine or Beam. It's built on the top of Erlang and provides a more readable syntax while retaining the concurrency and fault tolerance features of Erlang. These are just a few examples of popular functional programming languages, and there are many others that cater to specific domains or have their own unique features. Each language has its strengths and weaknesses, and the choice of language depends on specific requirements of a project and the developer's preferences. Key principles of functional programming. Functional programming is a programming paradigm that treats computational as the evolution of mathematical functions and avoids changing state and mutable data. It is a declarative style of programming where programs are constructed by composing functions rather than using imperative statements to modify data. Key principles of functional programming include immutability. Functional programming emphasizes the use of immutable data structures where once a data structure is created, its state cannot be changed. Instead of modifying existing data, functions create new data structures with desired changes. Pure functions. A pure function is a function that given the same input always produces the same output and has no side effects. Side effects refers to any changes that a function makes outside of its local scope, such as modifying global variables or printing to the console. Higher order functions. In functional programming, functions are treated as first-class citizens, which means they can be passed as arguments to other functions or returned as values from functions. Functions that make other functions as argument or return functions are known as high-order functions. Recursion. Recursion is commonly used in functional programming instead of traditional iterative loops. It allows solving problems by breaking them down into smaller, similar sub-problems. Function composition. Functional programming encourages composing functions to create more complex functions by chaining them together. Functions composition enables a modular and concise way of building programs. Referential transparency. This property states that a function's return value can be replaced with its result without changing the program's behavior. In other words, a function's behavior should depend only on its argument and not on any external state. Functional programming languages include Haskell, Scheme, Clojure, and Erlang among others. However, many mainstream programming languages like JavaScript, Python, and Ruby also support functional programming feature to some extent. Functional programming also comes with their set of challenges and limitations. Step learning curve, performance overhead, limited industry adoption, concurrency and parallelism challenges, mutable state interaction, debugging, complexity, limited performance, optimization, not suitable for every problem domain, memory usage, lack of mutable data structures. Despite these challenges and limitations, functional programming has many benefits such as improved code readability, reduced side effects, better code maintainability, and support for parallel programming paradigms. The choice of programming paradigms depends on the specific requirements of the project and the expertise of the development team. Functional programming can be a valuable addition to a programmer's toolkit even when used alongside other paradigms. Functional programming languages include Haskell, Erlang, and more recently JavaScript, Python, and Scala, which offer functional programming features alongside with imperative programming. It's important to note that functional programming is not an all-or-nothing approach, and many modern programming languages support hybrid paradigms, allowing developers to use functional and imperative styles together. Functional programming provides several benefits such as improved code clarity, maintainability, testability, and easier reasoning about program behavior. It is particularly useful in parallel and concurrent programming as the absence of shared state reduces the chances of race conditions. However, functional programming may not be the best fit for every scenario, and the choice of programming paradigm depends on the specific requirements of the project and the preference of the development team. A combination of functional and imperative programming styles can be employed when it is appropriate to achieve a balance between code simplicity and performance optimization. So we have here the reference in this presentation. Thank you for watching, guys. I hope that you have learned something new in this video about functional programming. Don't forget to like, share, and please support my channel, guys, if you're new by clicking the subscribe button. See you in the next video tutorial, guys. This is your friend Jake saying bye bye for now.